I am speaking with
Juval Löwy.
Juval. What do you do?
I'm a software architect. I'm the principal of IDesign. We specialize in software architecture and the related process.
All right. Well, that was your talk this morning: architecture and process. What are the highlights?
So I had actually two sessions. One on how to orient your process to accommodate the highly modular nature of a modern software system. And the second session was on what I call the Zen of architecture, which is how you actually do architecture. It never ceases to amaze me that most people simply don't know the very basic of what to do and what not to do with architecture.
So let's talk about that second one right there about architecture. What is it that people don't know and that they should be doing?
Most people do architecture in a functional way. So they look at the required functionality. They need to do A and then B and then C, and they have the A service, the B service, the C service. And that's called functional decomposition. That's the kiss of death for a good design. And the reason is, as the functionality changes, if you design your system this way, your design will change. And the hallmark of a bad design is when the design has to change to accommodate change in the requirement. The good way of doing a system design is to encapsulate what will change. I call it volatility-based decomposition, where you look at what will change in a system, and you encapsulate that and implement the functionality by integrating the areas of volatility together. And therefore the functionality is not in any particular place, it's in the integration of these areas. Now, as requirements change, nothing in theory changes in your design because the composition doesn't change, just the way you put the things together, which is a far easier things to come to terms with as far as the change than changing the actual architecture.
That's pretty impressive. So this is a credo that you've lived by for a while?
Yes, so at IDesign, we've developed this thing we call the IDesign method, which is a near mechanical approach for doing this, because in a software system there's typical things that change. So we have this approach where we look at the requirements, we distill out of it the core set of use cases. Out of that we come up with a set of building blocks that satisfy the core set of use cases. By putting them together in a particular way, we can now satisfy any particular use case. Then we superimpose on top of that a whole set of other design aspects that pertain to how the system is required to behave at runtime. And we can do this whole thing basically in a week. And basically secret sauce is the ability to come to a customer and do the entire design in less than a week. And that's basically what I was sharing with the audience today, is how to do that.
Do it in a week. That's pretty impressive. Now, how does this bleed into your process talk as well?
So you can't really separate architecture from technology or process. They're actually continuum. There's no point in designing something the technology will never let you build. There's no point in designing something that your team cannot build because the way they're set up or put together is actually wrong. And so the other session I had was on how to orient your process to accommodate a very modular architecture. How do you design the project, if you will? Because if you take this mindset, the actual act of project plan is actually an engineering task. It's designing the plan. It's how to assign the resources against the services and the order in which you're going to integrate it and such. These are all engineering questions. And I had a session that basically shows, okay, so given an architecture, how you design a plan around it.
How you design the plan around it. And so when people are developing a plan, what are they missing, I guess? I mean, because I know I always feel that my plan is never sort of well thought out enough.
It's exactly what I said before. It's designing a plan. So if you have a set of services and you know the effort estimation for each, the duration of the project is absolutely not going to be the sum of all services divided by number of developers, right? That's like asking how many months it takes 9 women to produce one baby, right? It's not going to be 1 month, right? So you have to understand the dependencies between the services, and the dependencies and the effort estimation, understand what is the critical path that we should progress as you implement the services. Then you ask yourself what kind of resources I need to satisfy that critical path without slowing it down. Then on top of that, you look at how you plan to earn value as a function of time, and you ask yourself a simple question: does this plan make sense? And if it does, great. If it's not, you revise the plan, or sometimes even the architecture, to make it feasible so that it actually can be built with an adequate risk by the developers you have at hand, right? And now that's all a set of priorities and trade-offs, which are basically engineering tasks. And what I show architects all over the world is how to take the architecture they've created and then take it to the next phase, which is the project design around it, give that to the project manager to make the managerial decisions around the information that they produce.
Excellent. Thank you so much for your time.
Thank you. Great to be at Code Camp.